Hello, everyone, and welcome back to another Planetarium show. My name is Jessica. I'm the director of the Planetarium, and with me tonight are two of our students who I'll let say hi and introduce themselves, and we'll start with Eli.
Hi, my name's Eli. I'm a physics and astronomy student at UMD.
Hey, my name is Braden. I'm a music education student here at UMD.
So tonight is another edition of Ask an Astronomer, where we are here to answer your questions. So feel free to go ahead and start putting those questions down in the comments. We will start answering them as questions come up. But as we give that a few minutes for those questions to start rolling in, we do have a couple of cool kind of astro news topics to bring up, and I guess we'll start with the one that most people, I would say, are the most excited about, and that's the probable, possible, actual launch of the James Webb Space Telescope, which I just found out was delayed 2 more days. So it was originally slated for December 22nd. They've now pushed it to December 24th because there's been a communication problem between the telescope and the rocket that it's flying up on. So they have pushed it back 2 more days, but still, we are so much closer than I ever thought we would be. I mean, it is there at the launch site. It is attached to the rocket. Things are ready to go. We're just finishing those final checks and waiting for a good launch weather. I have been hearing it's going to launch soon since, when was it first supposed to? Like 2007, I believe?
Yeah, somewhere around there.
Was the first projected launch day or launch year. And here we are, end of 2021, hopefully finally getting it to launch.
Yeah.
And I am beyond excited for this because the things that it's going to be able to see, it's going to be amazing. So for anyone who maybe doesn't know a whole lot about the James Webb Space Telescope or space telescopes in general, James Webb is supposed to be not the replacement for Hubble, but more of the predecessor. Why can't I think of the word? The next in line.
Antecessor?
No.
Antecedent?
What? Okay, I'm just going to ignore. It's the next in line of like space telescopes. So it's not a straight up replacement because it's not going to be looking at the same type of light that Hubble is looking at. Hubble looks at visible light, which is the light we see with our eyes, and it also looks at UV light, which really can only be done from space because our atmosphere does a fantastic job of blocking most UV light from getting through, which is very good for us living organisms down here on the surface of the Earth. So Hubble looks at that. It's also in orbit around the Earth and was put in an orbit so that it could be serviced by space shuttle missions, which was very, very good since when it first launched, there was actually a defect in one of its mirrors, and we had to have one of those shuttle missions go up to put a corrective lens on the telescope to correct for that defect. Basically, it got a pair of glasses. So James Webb is going to be quite a bit different. First off, it's 3 times bigger. The mirror is 3 times bigger than Hubble's, which is quite a feat because that's not a mirror that you could just launch as is. It has to do this origami fold up so that it can fit in the rocket to launch, and then when it gets up into orbit, it'll unfold itself. So there's one big challenge. James Webb is also not going to be in orbit around the Earth. It's actually going to be in orbit around the Sun. It's going to trail behind the Earth as Earth orbits the Sun. And this is very important because James Webb is going to be looking at infrared light. So infrared light is typically, you sense it as the feeling of heat on your skin. But the Earth is hot, so it gives off its own infrared light. So we need the telescope to be far away from the Earth so that the Earth's signal doesn't, give us false signals and obscure what we're trying to look at in space. But the reason it's looking at infrared is that's going to let us see the very first stars and galaxies that formed in the universe, and is also going to help us study planets around other stars. So there is going to be, if it launches and unfolds successfully and gets into orbit successfully, this is definitely going to be starting a new era in astronomy where we're going to have some amazing stuff coming in. And I'm actually, Eli, a little jealous that you are heading to grad school at this time because it is very likely you're going to get in on the ground floor of some of this stuff, depending on where you go and who you work with.
Yeah, I'm excited. This book right here is probably going to change a lot.
And that book has not changed in decades.
Yeah.
Because the edition you have and you use is the exact same edition that I used in undergrad and grad school. Yeah.
I was talking to another professor at UMD about like kind of the differences, and he said that when he was in grad school, they didn't like dark energy was like not like when somebody started talking about dark energy, people are like, oh yeah, right, okay, and now it's like pretty important.
Yeah.
So I'm excited to see what's gonna be pretty important that's not in here.
It's going to be great.
Yeah.
Very excited. Definitely making that itch of like, I kind of want to get back into research now.
Yeah.
Especially for the first galaxies and stuff. I mean, galaxy evolution is what my research was on in grad school, and this is going to just shine so much new light on everything.
Yeah. It's going to tell us a lot about like cosmology and stuff too, like the early universe. It's going to tell us a lot. We'll be able, a lot of what we know about the early universe comes from, this is what we think things were like, and how much stuff there was and how that turned into galaxies. But when we know precisely how much stuff there was by looking so far back, we'll be able to get a lot more concrete answers. I'm excited.
Yeah, be able to actually see those first structures.
Yeah.
Yeah.
Yep.
Very excited.
We should maybe explain what it means when we say we can like see stuff in the past.
Oh, yeah. So this is probably my favorite fact in astronomy and about telescopes in general. Telescopes are essentially a time machine. Because light takes time to travel, if we're looking at, say, Alpha Centauri, which is the closest star to us, it sits a distance of 4 light years away from us. And what that distance means is that's the distance it takes, or the distance that light travels in 4 years, which is something like 24 trillion miles or something like that.
Yeah.
So, or for that full 4 light year distance. So because light takes time to travel, you're seeing light from the star that left 4 years ago. So you're seeing the star as it was 4 years ago. Now, if we go even further and look at, say, the Andromeda galaxy, 2.5 million light years away, we're seeing that galaxy as it was 2.5 million years ago when that light left. So in order to, or basically the further away we look from the Earth, the further back in time we're looking. And so James Webb is going to be looking back to the very early universe by looking at these things that are very far away and showing us what the universe looked like, which I think is just so cool that we can actually do that. We can see what galaxies looked like 10 billion years ago because we look at them at galaxies that are 10 billion light years away. And it tells us exactly what the universe was like. And so while we can't sit and watch a galaxy change and evolve over time, we can look at snapshots from different times in the universe and then fill in the gaps of how did this become this, become this. And that's how we've kind of pieced together the formation and evolution of our universe. And James Webb is going to let us look even further away than we've ever been able to look before and give us those glimpses into the very early universe that we haven't had so far.
So we've got a couple questions or a couple comments. from Maryville, Tennessee. Just logged in and trying to figure out the topic. The format today is we're just kind of talking about interesting and recent news in astronomy and just kind of, you know,
Free-form discussion while also answering questions.
Yep. Okay, so the next question, planetary occultation. When might the next occultation of Jupiter or Saturn by our moon that can be seen from North America?
I don't know.
Not long, I don't. Maybe I'm thinking of something else.
Yeah, do you want to do some Googling?
Yeah. While I'm doing that, they followed up with another trivia question. What is the downside to Hubble and Earth orbit?
I mean, other than Earth always blocking part of the view,
Yep.
Signals from Earth. I don't know, do you have anything in particular that you were looking for us to say? Since you said it's a trivia question, I'm assuming you know what answer you're looking for.
I'm wondering if it's not like, even though it's in the atmosphere or out in space, there's still like a little bit of atmosphere that it's looking through or something like that, like much less than James Webb will be looking through. Or not atmosphere, but pretty.
Yeah.
Okay, he says, don't Google occultation. How would you figure it out with the planetarium? Well, we have a really nifty time knob. And so we could just set the time forward and wait until it happened.
Yep.
The downside to Hubble is a thermal perturbation every 90 minutes as it goes through the Earth's shadow. Oh, I didn't know that. Yeah. That's interesting, actually.
That makes sense. Yep, makes sense.
Another person asked, how much distortion or dispersion of light and radio waves occurs when looking back through time in the telescope? Is there a concentrator to reveal a most accurate picture? That's kind of what the lens is.
Yeah, so it's kind of a tricky question to answer. For the most part, the things you need to worry about for light coming from objects really far away is anything that light might travel through, like a giant gas cloud or another galaxy, which would be gas clouds in the galaxy. The thing is, we know what that does to light after it reaches us. So we can subtract that effect out so that we're just looking at the light signature from the source. So there's been a lot of work done to understand exactly what happens to light as it travels to us, passes through gas clouds and galaxies and things, and we're able to get rid of all of that effect.
Yeah, like it causes like a magnitude change in the light, like things get dimmer. And so if we know like how thick the gas is and how much light it eats up, we can like correct it and make it look brighter. But that's kind of contingent on us knowing what it's coming through, which we can sometimes do.
And we can tell, so when light passes through something like a gas cloud, some of the light gets absorbed by the gases, and this creates a bunch of absorption lines in the light coming from it. We have a term for it. It's called the Lyman alpha forest. I know that sounds fancy, but basically we see this signature and we're like, okay, it passed through a gas cloud. We know that. But what's really cool is we can actually use that to trace out where those gas clouds are with respect to us. So we can say it went through a gas cloud that was 5 billion light years away based off of that signature in the light. So we actually can learn more about what's between us as well. I hope that's answering the question.
Yeah. Also, if we're on Earth, another kind of interesting thing is we can do like corrective optics. So like if it's an Earth-based telescope and light's coming in, the atmosphere scatters a lot of the light. But we can use, I forget exactly how it works, but you use like lasers and you like see how turbulent the atmosphere is at what time, and then you can like use that information to like unmess up the image. There's like these really cool diagrams and like videos of how they do it.
Yeah, but we can't do that for what James Webb is looking at because that infrared light actually doesn't make it through our atmosphere. So we can't look at these things James Webb is going to be looking at because the light just doesn't make it through our atmosphere. That's why we're putting it up into space, which is another kind of why we're so excited about it.
I feel like another aspect to that question is like, specifically it said when looking back through time. So like if you were looking at an object that was super far away or like back in time, and there was nothing in between us and that object, there wouldn't be anything distorting it. Like the light would just come to us. I mean, it wouldn't be as like clear cut of an image because you'd have less resolution the further away it is. But there's no like distortion if there's nothing in between us and the object. So time doesn't really have a bearing. It's just like what's in between us and it. But I guess time does have a bearing because it's like how far it is. Okay.
Yeah, it has a bearing on that. So like if things are going to be dimmer because of how far away they are.
Yeah. And the other gentleman commented, it seems in response to that, the universe is remarkably empty. With the naked eye, we can see the brighter central part of the galaxy, which is 2.5 million light years away. With amateur telescopes, the most distant object amateurs can see is the quasar 1.3 billion light years away. We cannot look out very far in the direction of the plane of our galaxy because there's dust and gas enough to block stars. Lots of stars. Yeah, big time. Actually, hold on. I want to bring up the butterfly.
Yeah. Which, if you were at the Adventure Through the Universe on Saturday, you saw what Eli is about to bring up, and I think I have to give you sharing.
If I can find it. So in regards to what this this gentleman is talking about, oh boy, hold on. So don't pay attention to my tabs. I'm working on an exam at the same time. But you can see there's like this hourglass shape, and this is, if we like map out the universe and what galaxies and stuff we can see, this is what this is what the map looks like. Each of these, I mean, is a galaxy or a quasar or some bright object. And you can see there's like these empty spaces right here. These empty spaces are the areas that we can't look through because the plane of the galaxy goes like this. So like there's definitely stuff, well, I shouldn't say definitely. There's a really good chance that there's stuff out here, but we just don't see it because we can't look through the plane of the galaxy. We're just looking at a bunch of gas and dust and stars. And I just got a notification or something.
I heard that and thought it was mine at first.
My girlfriend sent me a Facebook Marketplace ad for a rice cooker. That's really funny. But yeah, that's what.
Yeah.
That's what that is. The butterfly. Sorry, I lost my train of thought thinking about rice cookers now.
Hey, a rice cooker? That is a device that I've been wanting to get.
Mine broke, so I need a new one.
Well, there you go.
Yeah.
Now you have an ad for a new one.
Yep.
Okay, so speaking of other astronomy stuff, actually it looks like we just got a question.
Was there something new with the black hole that may have allowed light to escape? Not that I'm aware of.
Not that I'm aware of either. Let me look. Because I've definitely been looking at some news stuff, but I have not seen that.
Oh,
Do you see it?
light was detected from behind a black hole for the first time. So what does that mean? Like it just got a lens around the black hole?
Yeah, that's what I'm guessing.
Oh, okay.
Well, no,
that kind of by definition, black holes don't let light out.
But I understand why this would be like news if that was the case, if they were seeing light coming.
Yeah.
I can't find it.
We've been talking for a while.
We have.
This went by faster than I thought.
Yeah. We've had some fun stuff to talk about.
The gentleman that's been commenting studied physics at the University of Minnesota. I'm hoping to be listening.
Yeah, he's from around here. I've been working with him some, so hi, glad to see you. They are working to get their local planetarium back up and running. So I've been helping them out with resources and things.
He hears every speaker echoing. Uh-oh. Should put some headphones on.
I am not seeing any evidence of that in our audio.
I'll put headphones on. Okay, is that better? It says light from behind a black hole. So is that galaxy light from behind the black hole? I mean, it could be. No, it wouldn't be, because if they're getting that high of a resolution of a picture from the black hole, that's a black hole in our galaxy, I would think. So it's like light from probably stars behind it, moving around it. I would think. I don't know.
Okay, I'm looking at it right now. So give me one. Oh, this is from a while ago.
Still echo. Well, I'm not getting any echo. Hold on.
Yeah, I'm wondering if you have multiple tabs open, because I'm not
I don't have
seeing any signature in our audio.
I'm not getting any. I listened to the audio on the live stream, and I'm not getting any.
Yeah, so what this is saying is basically, yeah, it was light that from an object that sits behind the black hole that you generally would think that you couldn't see because the black hole would be blocking it. But because of how the black hole warps space-time around it, the light was bent around the black hole and traveled to us. So we were actually able to see something that generally you would think we wouldn't be able to see.
Was it a black hole in the Milky Way, or was it a?
No, it's in another galaxy. It's the supermassive black hole in another galaxy.
Oh, so it probably was something from outside of the galaxy. Well, I guess I don't know, but well, I mean that would make sense.
So yeah.
Massive galaxies bend light, aka lens light. See Einstein.
Yep.
Einstein rings a pretty good. Not to be confused with ring galaxies, aka Hode's object. Or Bertrand's galaxy.
Speaking of black holes and warping space-time, so all of this was a work predicted by Einstein when he set out this general theory of, well, it wasn't theory at the time, it's theory now, the theory of general relativity, which brings me to one of the other topics that I had actually looked at, which was there was some more recent evidence to very strongly support this model of gravity. There was a study conducted of a pulsar system, and there were 7 predictions made by general relativity that they were able to test, and all 7 predictions were found to be accurate, which is an unparalleled level, unprecedented level of just testing and accuracy for this. Yeah. Which is really awesome that we're still seeing so much support for it. And I know this could lead to people asking, well, why are we still testing it if there's so much confirmation? And the biggest answer is because that's what scientists do. I mean, as we get better and better technology and more understanding of the universe, we want to keep testing things to see if they do eventually break, because that's how we learn something new. And we do know that there has to be something we don't understand, because relativity and quantum mechanics don't mesh together. And in everyday life, we don't need them to. But when we start looking at conditions like the very, very early universe and like Big Bang, or at the conditions like inside of a black hole, we need the two to mesh together. And we haven't been able to make that happen. And so by continuing to test relativity and do these sorts of tests, we're able to find where those cracks may be in the model and help us better understand how everything is supposed to fit together. But also, it's just science. You keep testing things.
Braden, what do you think?
Yeah, you've been quiet.
I'm not gonna lie. The reason for that is that I don't really have a lot to add to the conversation.
Well, this is your
I
first Ask an Astronomer.
so like I'd be talking more if I had more to add. I won't lie.
It's okay. You're starting. You're learning. You're here, and that's what matters.
Yep.
Is that a taco on your hat?
It is a taco on my hat. Thank you for noticing. I think it's pretty cool.
You have the
I
weirdest collection of hats.
I do.
And I mean that
this.
in the best possible way.
Yes, I take a real sense of pride in the hats that I own. So
Does the universe? We just got another question. Does the universe make sounds? I listened to some radio waves. I think. Is there a purpose for the sounds of the universe?
So, short answer, yes, but we can't hear it. So here's the thing. In order for sound to travel, there has to be some sort of medium for it to travel through. So for us here on Earth, when we talk, what the sound does is it vibrates the gases in the atmosphere, which vibrate the ones next to it, and that allows the sound to travel to, another person's ear. The universe is mostly empty. There's nothing there to carry the sound waves. So while things may do things that could make sounds if the sound could travel, it can't. I know there are places that do things like taking radio waves and converting that to sound, which, another aside, radio waves are actually light, they're not sound. And it's a little confusing because we think of the device that you hear out of as a radio. But what's actually happening is the radio station is communicating with your radio with radio waves, light waves. And then once those reach your radio device, they're converted to sound waves that come out of the radio speakers and make it to your ear. So I know that there are places and there are projects that will take radio waves and convert them to sound to kind of be like what it might sound like. There's also a way of visualizing data called sonification, which takes light and maps it out as if it were sound. So like if you had like here a starry sky background, you could assign each color of the star a certain note, so that as you scanned over the sky, you'd hear all of these notes associated with each of the stars. And that's not exactly the same thing as like they're actually being sound from the universe.
Yeah, I know there's been stuff where like probes at like Jupiter and Saturn, they'll be like these are the sounds of Jupiter and Saturn, but it's not the sound, it's the light that the probe gets hit with that then it turns into sound, a lot like a radio.
Yeah.
Questions for Braden. You ready, Braden? First of all, how did you hear about this program?
Mostly just like I just found out about it ever since like I started coming to ever since I applied to school here. That's basically how I found out about it.
Basically, it was a listing on the job board for student jobs.
Yes.
Yeah.
Basically, yeah.
Have you binoculars or a telescope with which to observe?
I have some binoculars at home. I could never afford a telescope, I won't lie. But because they are expensive.
But you now have some with the planetarium.
Yeah.
Exactly. No, but I do have a pretty nice pair of binoculars at home.
And then, are you close to the Duluth Planetarium? I would say so.
Absolutely, yeah. I live on campus, so
I think it means more like like, well, I don't know, I could be wrong, I don't want to put words in his mouth, but like, are you like
From this
in-
area?
no, like intimate with
Oh.
the planetarium, like involved with them? And I would say you're
Yes.
probably pretty involved.
Yes.
Being
yes.
a student
pays
worker,
you.
yes.
Yeah.
Yes. And I'm just here. I just like tagged along for this.
Yeah.
For this.
No,
this
he
meeting.
Zoom bombed us, and we
Yeah.
liked him so much we just kept him.
I don't know how you got the Zoom link for this, but
I just type in random Zoom links and type in random passwords to it, and it just works out.
this is the 4 trillionth link you've typed in.
Yeah, exactly. Yeah.
Oh. No, you've been great. Honestly, I think seeing you and Rachel at Halloween
Yeah.
was so fantastic. So for anyone who
you.
didn't come to our Halloween event, how dare you? No, I'm kidding. Rachel and Brayden put on a fantastic Harry Potter inspired magic demonstration
Mhm.
with magnets.
Yeah, it was pretty cool.
And they
It was really
did
fun.
fantastic. The kids seemed to really love it.
Yeah, it was really fun.
All right. Well, I think we are at our half-hour time. Eli disappeared.
Yeah,
Oh no,
sorry.
there he is.
But we just got one more. He says, I'm from St. Paul, Minnesota, but live in Maryville, Tennessee. I'm from Stillwater.
I'm from White Bear, so yeah.
I visited the Duluth Planetarium some years ago and found the webpage recently. Well, thank you.
Yeah, I think it was you were
Oh, thank you.
you were looking for resources, I think, for help
Mhm.
with restarting your planetarium,
That's cool.
which I hope goes well. I really do.
And
Yeah.
Jill says she's from Anoka. I've been to Anoka
Oh, gotcha. Yeah.
once, and it was because there's like a old like decrepit. I don't know if this is like the right word, but like sanatorium there. And like a bunch of my buddies in high school like, we should go check it out. And he's like,
Is there a haunted? Really?
like I don't know if I don't think they do like actual. I think people just like
Break in.
enter unlawfully.
Halloween capital of the world.
Oh, is it really?
I feel like I have to go now.
Oh,
Yeah,
I didn't know that.
Really fun.
I didn't know that it was like a thing. I know there's like a sanatorium there, and my buddies were like, "You should go check it out." And then I got scared, so I didn't. But there was the state hospital. Yeah. And Forrest Erickson says long backstory. I'm assuming about the planetarium. But I saw that you studied at University of Minnesota. That's fingers crossed.
All right. I think we'll wrap it up there. Thank you, everyone. This has been a lot of fun. This has definitely been a good Ask an Astronomer. Before I head out, let me tell you about our last show coming up of the calendar year. On Saturday, we are doing another edition of our exploration series, which is going to take a look at nebulae, which are these big gas clouds in space. And we'll take an up-close look at them and kind of what they are, the different types, and all sorts of things like that. And then that'll be it for 2021. We're going to take a 2-week break for the holidays for all of our student staff to kind of enjoy the winter break. And then we'll be back at the beginning of January, back to our regularly scheduled programming. And maybe some slight changes coming in February. I'm just gonna leave it at that. We'll just have to pay attention and find out what's going on. All right. Thank you again, everyone. We hope you have a wonderful rest of your day. For those in kind of southern Minnesota area, please stay safe out there tonight. I know the storms are supposed to be getting really bad tonight, so everyone please stay safe. And we will see you next time. All right. Bye, everyone.
Bye-bye.